her BTech in Electronics and Communication Engineering from Durham University in May 2011, and her MPhil in VLSI Design from VIT University. Currently working as an associate professor in the Department of Electrical and Computer Engineering at the University of Texas at Tyler, Texas, USA. She leads a multidisciplinary research group as the director of the Center for Robotics and Intelligent Systems, mentoring graduate, undergraduate, and high school students. The team has received multiple accolades, including Best Paper, Poster, and Pitch Awards at both regional and international conferences sponsored by IEEE and ACM. Her research has led to successful funded projects totaling over 1.7 million for organizations like NSF, NASA, Oracle, USDA, and the Renewable Foundation. Her research is in the emerging areas of the Internet of Things, on-device learning, bio-inspired robotics, agricultural robotics, and applied ML. She has published over 85 papers, holds 3 U.S. patents, and has an HX of 7. Dr. Sundaravadivel has been recognized as a faculty scholar at the 2019 Grace Hopper Celebration for Women in Computing and 2022 Richard Tapia Conference. He was named as Innovation Fellow by Renewable Foundation in 2023. He was recognized as Outstanding Early Career Researcher in the IEEE Bio-Inspired Technical Community. He has received over 37 awards from multiple venues for her research.
Thank you. HDMI connect பண்ணு. எங்க இருக்கு HDMI connect? Hello everyone, good morning. I'm Dr. Prabha Sundaravadivel. I'm sitting here from University of Texas at Tyler. So first of all, really sorry for the delay in getting things started. We are running into some technical issues, so we were just sorting it out. We will have the session next 2 days. We will have it more interactive. The way we have planned is today is going to be more of theory and lecture. Tomorrow we have hands-on session. In the on the hardware board, we are going to implement whatever we are discussing today. So it's not just going to be a one-way lecture mode. On the other note, today also we have some hands-on model planned. So maybe first I'll go over the theory part and then we will start with the hands-on one. Okay. So for the hands-on that I'm talking about for today, I'm going to teach you all the Arduino programming. So all I need is a laptop. You can connect it with your phone as well, but laptop would be better. If you can just connect it to the Wi-Fi, it should be fine. You can just open, it's a web-based tool, so as long as you have Google Chrome installed in your laptops, it should be fine. Okay, no need to have any software for today. All right. So in the next 2 days, I'll get to know each one of you because he already started late. I'll just get started with the lecture, and any feedback, anything you have, please feel free to share at the end of the workshop. Yeah. All right. So like sir was mentioning, HOD sir was talking about how a controller is very important. In the present day autonomous systems or any smart system that we are talking about, the controller plays a very important role in that, right? So what is the role of a controller? We are going to use it for programming the hardware. Hardware itself is sufficient enough for doing whatever task, right? But we are trying to make the hardware smarter by teaching them what exactly needs to be done. Say at 9 o'clock do this, 10 o'clock do this, like in certain time intervals or in a certain way, how to actually execute the whatever the required action it is. That's what that's why we are using the controller. But in the present day systems, we are talking about smaller electronics there because we don't want to carry a laptop as big as this table, right? We want sleeker designs, we want smarter cars, we want smart systems around us. So the machine that is going to be used for programming it also needs to be small and efficient. That's what we are trying with this. So here we are talking about, we are going to see first what is a microcontroller. First of all, am I audible to everyone at the back? And is this readable for everyone? So what exactly is a microcontroller? It's nothing but a very small low power computer. It's essentially a smaller computer that we are going to use for programming whatever the system we want to use. So our learning is on how to program this chip now. But present day, we don't just use a microcontroller as it is, we use some development board. What is the purpose, what is the advantage of using a development board is that we don't have to worry about how to connect the input and output to it directly and everything. So this kind of microcontroller here that we are seeing has a few amount of memory in it already. So our laptops have like say several GBs of memory in it, right? This might not have that much of a memory, but it's still good enough for executing the program that we want the hardware to understand. So the way this has revolutionized is microcontrollers are very inexpensive to start with. You can get a bunch of like good microcontrollers for like simpler tasks. It can start from say like $2 to $5. We can get a very good one, and it comes in a pack of 5 and so on. So it's a very cheaper way to make things smarter around us. And also this is all general purpose input output. What does it mean is we don't have to necessarily configure it for a specific design as such. You can just take one microcontroller, you can use it, you can connect it with a temperature sensor and monitor this room's temperature, or you can use it as a light monitoring device with probably some light with some sensors for that, light intensity sensors for that, or you can use it for like tracking how the drone is moving and all that, or any of the systems how fast it is moving and everything based upon the IMU unit. So you can configure one microcontroller into any type of application that we want. And essentially now if you see the like a modern car, it's more of a electrical device than a mechanical device. It has lots of chips in it that is helping us to automate things by writing. So what they have done is they have developed all these kind of chips and put it in the car. That's why we are able to like say the reverse parking sensor is there, lot of sensors are around the car itself, and it has become much more like a smart electrical device than just a mechanical device lately. So the way this Arduino has evolved is that first it was very difficult to program the microcontroller board itself. So if you take that microcontroller chip, if you want to program in this, you need to learn assembly programming. You need to understand what exactly is happening at each register level and so on. So one graduate student in 2003, Hernando, he kind of developed this project called wiring, which was developed based upon like one common platform for programming all these microcontrollers. So there was a microcontroller board. He made the input and output pins around it in such a way that anyone who wants to connect it to the sensor or anything, they can just they can just make that wiring connection in the input output side directly instead of understanding the assembly programming. Now this opened a wide range of opportunities for anyone who knew the C++ program also, because it was very the way they developed the syntax was very much like the C++. So it became a lot more easier for a lot of people to start working together. So this grad student developed the project called wiring, and that they made it as an open source platform, which means you don't have to pay anything to actually get to start working with this. You can anyone can download the software from the website, and if you know the Arduino programming, you can just start with it. So the wiring project later, it was further developed by his faculty advisors into a project called Arduino, where they kind of put a lot of such boards together. So there is a if someone wants a smaller board for a specific application, they can choose a board accordingly. This is a much larger board where you want to connect multiple input and output pins, input and output components. You can connect that way as well. So they kind of expanded it from a simple concept of using a microcontroller along with the development board all the way to multiple such boards. So lately, like after this was in 2003 to 2005 time. After that, many companies started making their own version of these development boards. They started having something customizable for different microcontrollers out there. So we are not restricted to just one product out there. Now, if after this workshop, if you are interested to pursue this for any of your projects, you can just choose based upon whatever budget you have to get started with, and what is the kind of input and output pins you want to connect with it. So in the next few slides, we will briefly go over what are all the existing Arduino boards or general Arduino boards that are out there. So, like I said, Arduino is an open source prototyping platform. So, it is you're not restricted to just purchasing the license and so on. Anyone can work on it. And the design itself, the microcontroller, along with the development board, those designs are also available out there online. So, if you are very hands-on and if you want to develop your own microcontroller development board, you can do that as well. So depending upon whether you want to just buy something off the shelf and start using it, or you want to make something for yourself, you can customize it accordingly. So it can, the major advantage for this is you can connect a lot of sensors through it, through the input output pins in the Arduino. So this has increased the opportunities or like the venues where it can be essentially used, not just limiting to a certain application. As long as we can have a Arduino board that has necessary power supply, it can activate multiple other devices around it. So that is a major advantage we have. So all we have to know for this is to write that small piece of code so that you can use the Arduino for your own application. So whenever we are designing something with the Arduino IDE, so in this class, in this lecture, we are going to talk about the Tinkercad. That is the platform from Autodesk that is also open source. We are going to develop our projects from there. But if you want, like later, for actually dumping the code in the hardware, you will need the Arduino IDE software, that is, which is open source, and you can access it from the Arduino website. So these are the different types of Arduino boards available out there. Let me just go over quickly about each of these boards, and then maybe that will we can have some interaction section after that. Okay. So the first one we are going to see is the Arduino Uno board, which is kind of a very basic board. This is the Arduino Uno board. It is not too small, at the same time it's not too big as well. The architecture is very simple for us to understand what is happening in here. So here if you see, this is the microcontroller that we have. That in the very first slide, the Atmega microcontroller we saw, this is a microcontroller. What they have done is they have they're already manufacturing it with all these input and output pins in such a way that now you just have to purchase this board, connect it to the power supply, and connect the input and output pins accordingly. Whether you want to connect a sensor to it and then program it accordingly, or you want to put a LCD display there to see what is the output, or you want to put some LEDs there to just blink whenever there is something happening, all that you can customize based upon whatever is your framework that you want to develop. So in this Arduino board, we also have the chance to connect to the power supply here for the additional input output pins that we will be connecting. So this is a very self-sufficient board. It itself like has some LED on it. In case if you just want to learn when we start with the basic programming, we can just see whether the board works or not by blinking the LED on the board. Okay. So here is just the specifications of the board in general. It, like I said, as long as you have that board and a USB cable for it, you can think of n number of frameworks that we can develop along with it. Next is the Arduino Mega board. This is slightly bigger than that. This has Atmega 1280 microcontroller on it, and it has 54 digital input and output pins. So this is the Arduino Mega board. Like you can see, than the Uno board, it is slightly bigger. It has a lot more pins. So if you are thinking of a project which might have multiple input output pins, then you can go for something like this. Then we have nano boards. This also has a Atmega microcontroller, but this is kind of really small. This is the architecture for Arduino Nano. So this has lesser number of input output pins than the Arduino Uno board. But here the advantage is, now example, if you are going to design some monitoring device that probably needs to be placed on someone's hand, or probably you need to just have multiple such devices together, right? But you don't want it to be too bulky to see what exactly is happening there. Then you can go for a nano board like this, which is very small. So along with the sensors and everything, you can package it in a very small framework. Then we have Arduino mini boards, which is even smaller than that, smaller than the nano board also. But usually the mini boards, whenever you are like purchasing these kind of boards, one thing you have to make sure is that it has the headers for connecting the input and output pins. Otherwise, you will have to solder it manually, the input output pin wires and everything. Okay, so the black frame that you all see here, these are the headers for connecting the input output pins, which is not there for this one or this one. Yeah, so when you are purchasing the boards, be careful, choose the ones that has the headers. Nano boards also has those headers along with it. You just have to make the right choice when you are purchasing the boards. Okay, if you are someone who don't have that soldering experience and all that, better to purchase something with the header so that it is easier to connect. Then we have Arduino micro boards. This is the architecture for Arduino micro. We also have now in this PowerPoint, we are only talking about the Arduino variations of different sizes of the boards. There is also ESP expressive boards. There are like several other variants out there in the market. ESP boards are kind of very similar to the Arduino micro architecture, where we still have that microcontroller here, and we have very limited input output pins to go with. So this is another version of Arduino board. This was popular for using it for the like watch kind of frameworks or any of the wearable frameworks, where we can like connect it in a round shape, and we can just package it in that fashion. Okay, before we go on to this one, any questions? All right. So we talked about the Arduino boards. Let's take probably like 5 minutes and think about any of the applications that we can design based using these Arduino boards. Because like I said, with the microcontrollers, there are n number of projects you can do. Not just a simple temperature monitoring system or so. Like even in the satellites, aircrafts, they are still using some kind of like automation like this with help of these kind of boards. I'll be going over the different types of boards, but the microcontrollers play a very important role in a lot of automated systems around us. So just think about what all can we do with help of these kind of microcontroller boards. Just think of a project idea. We'll just make this more interactive. Yeah. What is it? Gas detecting sensor. Yeah. So we can just connect that sensor to one of the input output pins that we have. Let me keep the Uno so that we can just connect the sensor here. Now, whenever we are connecting a sensor like that, how do we understand that the sensor is detecting some values or not? Yeah. like a buzzer. We can set up a buzzer. We can also set up a LED just to blink a light whenever something is not working. Yeah. Anyone else? Weather monitoring. Okay. What all sensors can we have in a weather monitoring? Hmm. Pressure, temperature and humidity and pressure, maybe. Yeah. Then how will we give the output to the people? You can show it in the dashboard. Yeah. Are you talking about your final year project? Okay, okay. Yeah, we can do that, definitely. So in a simplistic way, because we are talking about only the Arduino boards here, we can make it show in the serial monitor itself, whatever is the output. Yeah. Anyone else? I need more answers.
Access an interface of like from the computer to the PLCs or something. So I have replaced the controllers with micro that aspect.
Okay.
So using the Wi-Fi I get data to the computer
Hmm.
and using the microcontroller I process it and I send to the PLC. So PLC
Okay.
can't get the data directly, so using the microcontroller as an interface.
Okay. Okay. Yeah. That is like part of the automation there, right? Okay. Anyone else? It doesn't have to be a correct answer. I just want to make sure that everyone is on the same page before I keep talking about the next set of slides. Yeah. One more answer. Anyone else wants to try?
Bluetooth control card.
Bluetooth control car. Okay. So how? Huh? Health monitoring system we can have. Yeah. So in a Bluetooth control car, how will what would be the framework there?
Bluetooth module.
Ah,
Motor driver.
ah.
Motors.
Everything connected to the microcontroller. Yeah. So the input can be given using their this one any device. Yeah. Anyone else has an answer? All right. Okay. So this is the simulator that we are going to look at in today's workshop. So this one is a Tinkercad. Tinkercad is a free tool that is developed by Autodesk. All you have to do is just create a login in there. So in Tinkercad itself, you have you can connect it. You can design your own 3D models there. So it's like a another version of if you have used Fusion 360 and all that. You can this is like a another tool for it. You can also use it in this workshop. We are going to talk about specifically using it for programming things on Arduino board, because every time you might not have a Arduino board to get started with, but you can use a Tinkercad. You can simulate, you can run the code, you can simulate it. Once you are confident of what is happening, then you can purchase the relevant hardware for it. So it kind of reduces the overall cost also for us. Yeah. So if your laptops can connect to the internet, or if you just want to check it on your phone, please connect it to www.tinkercad.com. If the Wi-Fi is not working, also we can like talk about the electrical engineering concepts around it. ಇದು ವರ್ಕ್ ಆಗುದಾ ವೈಫೈ ವೈಫೈ ವರ್ಕ್ ಆಗುದಾ ಇಲ್ಲ ಯಾಕೆ ವರ್ಕ್ ಆಗಲ್ಲ Okay, I think there is still a technical issue. We don't have the Wi-Fi yet. So we will revisit this Tinkercad shortly. Let me just go over the other hardware components associated with. All right. So while we wait for the Wi-Fi connection and all that, we will start discussing on the hardware components around the Arduino. So when we are using these microcontrollers, we need to make it into a circuit. Can I have everyone's attention here, please? So we need to make a circuit out of it, because if you just have a open-ended, just a microcontroller connected to the USB, we cannot just connect the sensors as it is, right? So how do we make a circuit? So in a layman terms, if you see, circuit is nothing but making a free flow of charges inside in such a way that we can call it as a current. So whenever you are configuring this Arduino board on the breadboard, we should make sure that there is a closed loop there, so that there is a flow of current continuously. Otherwise, if you just leave it open ended, then we might not be able to see the results from the sensor and so on. The Arduino board will be powered using that USB plug. When you connect the USB plug to your laptop, that will be powered. But we need to still connect it to the other components, right? The sensors, the LEDs, and motors, all these things, we still need to connect it to it, right? So for that, we need to make a circuit where we need to make sure that we are having a close connection there, nothing open ended. So when we are talking about this circuit, these are like few terminologies we'll be revisiting again and again. So I'll just go over those definitions. So a load is nothing but whatever, whenever we connect to the circuit, this load is what is going to consume the power. Now, say if you are connecting a sensor to your Arduino board, and that sensor is where like sensor is consuming the power, where it is going to give out some readings after it, right? Be it if it is a temperature sensor, it's going to give some temperature sensor values. If it is a pressure sensor, it's going to give the pressure sensor values. So it is consuming some power. So this is the load that we are connecting to it. So the load is the one that consumes the power in the circuit, whereas the ground is the return path. So whenever you are connecting the Arduino, you have to make sure that you are making that ground connection also. In the board itself, there will be a ground pin. You have to connect that one as well. And in case if any part of the wire is going to be disconnected or cut, then it is called a open circuit. Okay. Similarly, when there are like additional unintended components that is going to draw infinite current, that is, for example, if your device is your circuit is designed for say like 1 ampere current, right? But you are putting some component there which is just drawing infinite current there, then it will be a short circuit, which means it will just probably like burst and so on. Don't take it as a joke, because it has actually happened whenever someone has started playing with the microcontroller boards for the first time. We have seen it fire up because they didn't connect these load and everything properly. So I'm sure most of you would have used a breadboard already, but I'll just quickly go over it. Now, breadboards are very helpful for us to make these connections in such a way that we can like see, we can connect it to the corresponding wires and so on. So there are like holes. This is a breadboard here. So on the top, it's a negative line and the positive line, and we have the columns here. So as long as you make any connection within this column, it's going to be the same wire. So if you are making any any joint components in a circuit. Now say point A to point B, if you want to connect, you can connect it along the same column. All this is going to work in the same way. Similarly, this horizontally is going to work in the same way. Okay, any questions? No? So in the simulation side, we can also, like in the Tinkercad, we also have the breadboard that we can just take and start using it. Now if you are someone who have not used a breadboard earlier, whenever you are doing the hands-on tomorrow, make sure that you understand exactly how the connections are being made. I know we have different classes of participants here, so I don't want to assume that everyone knows everything, so that's why I'm going over this. Okay. So then about reading the schematics. So now if you are whenever you are looking for some code online, so in case like if you want to connect a temperature sensor to a Arduino board, if you just type it in Google, you will see lot of already existing code and resources out there in the online. It's not something new, right? But what is the application you are going to use? That might be something new. Maybe they would have used a temperature sensor just for monitoring the room's temperature. You can customize it for probably like a healthcare wearable also, or specifically for like a plant temperature monitoring or water temperature monitoring. You can customize it however you want. Yeah. So whenever you are like looking up online for all these resources, you will come across the corresponding schematic design also. Whenever we are having the internet, we will see go over some examples there, but you will see the corresponding schematics where they have connected the sensors along with the microcontroller board and some components around it. So you have to understand what are the components around it. One very important component is the resistor, where the resistors are going to basically help us in regulating the current and voltage flow between the microcontroller and the sensors. Especially whenever we are using a LED, we usually connect it along with the resistor so that we don't burn up the LED. At the same time, we are having a much more controlled current flow over there. So whenever you want to control the flow of current, you can connect a resistor accordingly. Yeah. Then we have capacitors. Capacitors, for those who are not from the electrical background, capacitors are something that is going to store the energy for us. So it's going to store and charge and discharge as required whenever we are running the system. So capacitors can also be polarized or non-polarized. That is, it can have positive, negative, or it doesn't matter which side we connect as it is. But capacitors can be very helpful, especially if you are having a circuit that might have some fluctuations there. You can add a capacitor there so that those fluctuations are not affecting the microcontroller board. So we have to protect the microcontroller board essentially, because that might be the most expensive component that you have purchased and you are using. So that is why we are adding these components around it. Okay. Then we also have switches. Switches are something that so Arduino board itself, some of the boards might have a switch in it. The smaller boards might not have. So you can add a switch there so that you can do on and off accordingly. So one part, like whenever you are designing, say like a larger system, you can just switch off one part of it with help of this switch, right? So you can just cut down the current for that part of the circuit as required. That is the purpose of using the switch. So the switches comes as smaller push buttons that you can just push it down for switching on and off. Then we have the power, where if you want to this is like just using the DC, but in case if you want to like store it as part of the battery also, like for example, most of the times whenever we are using these kind of microcontrollers, we don't just connect it to the with the USB cable all the time. We don't connect it to the laptop all the time. We will write the code, we will put it on the board, and then we will have this system somewhere out there. So battery will be very helpful for us to make sure that it is powered up all the time. Yeah. Any questions? All good? Then we have diodes. Diodes help us in like having the current flow in only one direction, either positive to negative or negative to positive. Mostly it is positive to negative. So diodes can also help us in making sure that to test whether there is a current flow there or not. Mostly the LEDs are nothing but light emitting diodes. What is happening there is that when there is flow of current, instead of just passing on the current, there is a light that is going to blink there as well. That's the purpose of that. That's how the LEDs work. So we can, most of the times whenever we are configuring these prototypes, we will add a LED into some part of the circuit to make sure that we can understand that that part is powered up or that part is working fine. And we have some other ICs as well. So in the starting stage, maybe you might use just one or two sensors along with the microcontroller, but going forward you might use like much more complicated sensors also. So for example, if you are using a one sensor with all the temperature, pressure, humidity, everything together, that might just come as an IC, right? So you have to know how to connect that IC along with the Arduino board. The way usually sometimes it works is that, like for example, a motor and so on, in case if you just want to connect that motor directly to the Arduino, it is not possible because of the power grading between the Arduino and the motor. So we might use a H bridge or some kind of bridge circuits like that, that can help in regularizing the voltage flow between the motor to the Arduino in a much more standard way. Then we have the nodes in a circuit. A node is kind of like any point where two or more components are going to meet as it is. So if you are connecting A, B, so this would be a node there. Okay, where the connection is happening, this is a node. So we will be using the wires for making these kind of connections on the breadboard, and we can also use several other you can just use the different colors of wires so that you understand like which one is connected where. So usually for power supply we connect red, for ground we connect black, and for input outputs you can like make sure that you are using certain colors of wires, so that like you have a much more um, organized way of tracking where exactly, in case if something goes wrong, you know what exactly went wrong over there. Okay, so a little bit more electrical engineering concepts. We will talk about the resistance and Ohm's law. Ohm's law is kind of like everyone would have studied in the physics +1 +2. Everyone is aware of what is Ohm's law, right? So what exactly we are talking about here is whenever we are having a voltage and current, it has to the voltage and current has to vary linearly, right? This is the resistance we are talking about. So V equal to IR is a Ohm's law. Lot of the circuits that we are designing around we will like make sure that it follows the Ohm's law, so that we have a linear variation of voltage and current throughout the process. And we will also be seeing how to connect the resistors serial versus parallel. In some ways we will be connecting the resistors in series, where like if you are connecting it in series, it kind of adds up the amount of resistance you are adding, kinds of adds up to it. So this is a series connection, this is a parallel connection. So what is the difference? Can we have the mobile phones later, please? You all are paying to be here today, right? So this is how we are connecting in the series connection, where the end point of the first one is is connected to the starting point of the second one, whereas here all the sides are connected in the same fashion. So it is not a start or end point, whereas like if you want to just keep it as like point A to point B, everything is point A to point B, not connected in this fashion. So you need to make a decision of whether you want to have a series connected resistors for in case if you want to accumulate the resistances to have a much more controlled output, or just a parallel connection is fine. We will see both the kind of examples when we are like solving for some Tinkercad problems. All right. So the
Internet will not come today. We'll have to do on the
oh my God.
Yeah. So if you want to move ahead with the thing.
Okay, after this let's start. So then we'll just quickly see how to understand the resistor code. So based upon the which band resistor we are taking, we can like understand what is the capacity of that resistor, what is the value in the resistor. Now for understanding this, there are also some online tools where we can just see, if you just type resistor code, resistor color code, you can see that you can just mark this one and see. Generally, in case if we are using a 4-band resistor, so the first band is the first digit is usually in the green color, whereas the second digit, this is the multiplier and this is the tolerance level. The last one is the tolerance level. Tolerance level is like, say if you are using a 220 ohm resistor, it can go plus or minus 2% or 5% and so on. That is the up to that the resistor will still work. But if you are going to need much more resistance, it's better to change the resistor value instead of just playing with that. So the first one is the first digit. So for example, now because this is in green, this one is 5, right? And the second one is in blue. So this is like 56. We have 56, and multiplier, this is in red. So 100. So this is 56 into 100 plus or minus 2%. So we are looking at 5600 ohms with a tolerance of plus or minus 5%, the gold color. Okay, that's how we read the resistor one. So if you are given with a resistor, you should understand the value of it instead of the lab person telling you that this is the resistor, this is a 220 ohm resistor, which is a 100 ohm resistor and so on. Okay. So I'll just quickly go over this again. The first one is the first digit, second digit, this is a multiplier, and this is the tolerance level. Okay. So we will probably start with the Tinkercad just now. Looks like we are not going to have Wi-Fi today because of some technical issues. If you want, you can start with the, you can connect with your hotspots. Yeah. So even if you want to just try it in your phone, it's fine. You can start with tinkercad.com. tinkercad.com. So once you open the tinkercad.com, there will be a way to register over there. You can just create a login. எனக்கு யாராவது ஹாட்ஸ்பாட் கொடுக்க முடியுமா? Thank you. Thank you. So in the Tinkercad, you can either sign up or give a if you already have a login ID, you can just log in. So if you click on the projects on the top, you should be able to see the circuits here. We are going to be working with the circuits. Or you can also take it from the Tinker option on the top and then click on the circuits. Okay, thank you. Is everyone here so far? In that page, in the circuits, you would have seen start tinkering. You can click on that. In this page, if you click on create, it will ask you which one you want, 3D design, circuits or code blocks. We are going to be working with circuits, so you can choose that. Anyone has any questions, please feel free to call me. So this side, you would see all the library of components that's available to us. In there, you can search for the Arduino Uno board, and you should be able to find the Arduino board also. Once you find it, you can just drag and drop it like this. Arduino Uno R3. Has everyone been able to open it, the Tinkercad? Okay. So if you are concerned about the hotspot, you can like just stop it for a bit. We'll go over the coding theory and then we'll come back to the Tinkercad again. Okay? Nitya, you can switch it off if you want the hotspot for it, just for a bit. So now we are, I'll just quickly go over some basic syntax and everything for Arduino, and probably after that first blinking LED project we can take a tea break. Yeah. So what we are going to do now is understand how to program our Arduino. Your Arduino code is essentially, if you see, we are trying to talk to the machine that understands only zeros and ones. So earlier, this was kind of, if you know the register level programming, like assembly programming and so on, it was much more convenient because it was all just set of instructions to just move things around. But now we are trying to write it in a language that is also easily understandable for us as well. So it's not too complicated. Now for that we are going to we are for this particular microcontroller we are choosing the C++, where like we are going to have a compiler that is just going to transform the whatever instructions we are giving, it's going to transform it in the machine readable language. So we are just going to give some certain instructions and the compiler is going to take care of the translation between what we type and what the machine has to understand. Okay. So this one was in C++ was kind of found in 79 by Stutztrup, and so it kind of is based off the GCC compiler only. If you are already familiar with C++, you would be familiar with this compiler. Arduino program, whenever I'm saying Arduino program, it's a combination of C and C++. So we do have some headers and some functions that we kind of use it in the C++, the object oriented programming concepts and all that. The basic syntax is very much alike C. So it's a good combination of C and C++. But don't worry if you are not familiar with C and C++, because it's still very easily understandable whenever we are going over this one. Okay. So first let's talk about the syntax and the program flow. So syntax is kind of like the grammar for us, right? The machine has a syntax or like certain grammar of how it wants to and what it actually understands. Now whatever instructions we are giving, we have to give it in a certain format that it understands the exact same thing. So we have to follow the grammar that the machine follows. So that is why the syntax is very important. In Arduino, we have void setup and void loop, two functions over there. So we have void setup and void loop. So whatever instructions or commands you put inside the void setup is kind of like setting up the board for initially. So the input output pins that you want to assign, or the initial whatever the program, however you want the board to be prepared, you can put those instructions in the void setup. Whatever you want to keep running, like as long as the microcontroller, your Arduino board is going to be powered up, it's going to run the same instructions again and again, right? So whatever you want to run it in the loop, you can put it in the void loop. Now this example, if you see in the void setup, we are using the pin mode keyword. So whenever I'm saying pin mode, the way this is going to work is the first input has to be a pin number, whichever pin you are going to access. The second one should be the mode. So for example, if I am making a connection in the pin number 13, and if I want it to be an output, I write it this way. Yeah, pin mode 13 output. So whichever pin you want to assign, you want to actually like play with, you don't have to necessarily assign everything as output, right? Whenever you are connecting like multiple components together, if you want it to be an input or output, whichever the pin number you are making that connection, you can choose accordingly. So the syntax for this one is the pin mode is the first has to be the pin number followed by the mode of operation, whether input output or in both combined, depending upon your application. Okay. So Within the, now we have set up this initial part in such a way that in your Arduino board, that Uno board, we are accessing the pin 13 now, and that is our output. Okay, now we have to write more to see like what exactly is there, right? Pin 13 is usually the LED that is there on the Arduino Uno. So in the Tinkercad, if you can see, the pin 13 is the LED that we have, the onboard LED. So without making connecting any extra LED, we are trying to blink that one that is already on the board. Okay. So after writing the code, this is the LED board that we have. The LED on the board we have. So we are trying to access this pin, and we are saying that pin 13, this LED needs to be our output. Okay. We have assigned the pin 13 to output now. Now, but we didn't tell about what exactly needs to happen there, right? That is where we are going for. That is where we are writing these lines of code for it to go high and low. So high means on, low means off. So this LED, we are going to blink it on and off again and again, right? How we are going to do it? We are assigning the pin 13, we are giving a function digital write. So within the loop, I'm using this function digital write. The way digital write works is, again we are going to use the pin number followed by whether it has to be high or low. Okay, is everyone following so far? Any questions? Yeah. So once you write this one, there is also analog write. First we will talk about the digital write. In this digital write function, they have already written it in such a way that the first one is going to be the pin number followed by whether it has to be high or low, right? So first we are making this as high in such a way that the LED first blinks, first glows, right? It is on. After certain delay, it is going to go low. So this line of code, digital write 13 high and digital write 13 low, both are like same thing, just we are assigning it as high and low. But if we keep this high and low too short, then we cannot see what change is happening there, on and off, right? We need to give some delay in there. That's why we are giving the delay time units. Okay. Now can you all try this one in the Tinkercad? Just write it in the code on the Tinkercad. Tinkercad, if you see over here, after, I hope by now everyone has dropped the Arduino Uno board in the simulation, in the main area. Now just click on this code. In the code, you can see that by default it will come with the void setup and void loop function. Block program இல்ல அது திரும்ப கிளிக் பண்ணாது இதுல இதுல வந்து text default வருதா So when you click on the code, the default one you would see blocks. Please select text over there. In the blocks, if you click on the drop down box, text will also be an option. Select the, here if you see, give yes. Once you have written the, I think by default the code pops up there. Just make sure you understand what exactly is written there. Yeah. So after that, you can just click on the simulation part. There should be start simulation over there. Just click on that. And make sure that you close this code window, because otherwise you won't be able to see what exactly is happening. When you click on the simulation, you should be seeing the LED blink, pin 13. Yeah. You can now save this one. Whatever you are working on, you can save this one so that you can reuse it later. Like you can see, I keep using Tinkercad for my classes. So most of these files are like were written for my regular classes over there. So you can just save it, because whenever you are doing some advanced level of projects, you can save it and you can share that link with anyone else also. Okay. Any questions so far? So before you get out of this, make sure that you save it with a meaningful name, because Autodesk usually gives some random name for each file. Make sure that you rename it so in a proper name so that you can access it later. Okay? If you just click on that, it will ask for changing the name. Over here you would see the file name. Yeah, in the top corner. Make sure that you have it in a proper meaningful name so that you can access these files later as well. How many of you are done with this? Completed the blinking LED part? Is everyone done? I need the hotspot. Dicha.